characteristics of IGBT, insulated gate bipolar transistor. And this device is coming under the family of transistor, so they named it as a insulated gate bipolar transistor. So here we have three terminals, and they named the terminals as gate, collector and emitter. And gate is isolated, so it is named as isolated gate bipolar transistor. And this is coming under voltage controlled device. So here we are measuring only the voltage applied to the gate and emitter terminal, and here the voltage is measured across the collector and emitter terminal. And here ammeter is connected to measure the current flowing through the collector terminal. Okay, and this is the one of the source used to apply the voltage in between collector and emitter terminal. So we are calling it as a VCE, collector to emitter voltage. And this is the source connected in between gate and emitter, and this is called as VGE, that is the gate to emitter voltage. Okay, and this is the circuit. And now you can look into the characteristics of IGBT. So this is the output characteristics. It is drawn in between VCE and IC, and this is IC and this is VCE, and these two are called output parameters. So if that graph is drawn in between the two output parameters, and we are calling it as a output characteristics. And another one is a transfer characteristics. It is drawn in between the input parameter and output parameter, so we are calling it as a transfer characteristics. Okay, so the transfer characteristics is drawn in between VGE and IC. Okay, and you can observe from this figure that this characteristics is similar to our PJT. So you can refer common base and common emitter and common collector configuration, and this is the output characteristics. This is similar to the output characteristics of PJT. Okay, now you can look into the components required to conduct this experiment. So here this is the IGBT characteristics module, and here we have sources, two sources. Here it is offering 0 to 12 volt, and here these terminals offer 0 to 20 volt. Okay, 20 volt it offers. Okay, and here we have a option and provisions to connect voltmeters, then VGE to measure the voltage applied in between gate and emitter, and another meter can be connected here to measure the voltage applied in between gate and collector and emitter terminal, and one more terminal for connecting the ammeter to measure the collector current. Okay, so now I am going to connect the meters with this circuit. Okay, first I am connecting the voltmeter required to measure the voltage applied in between the gate and emitter terminal. So this is a voltage controlled device, so we need only the voltmeter to measure the voltage applied in between the gate and the emitter terminal. Okay, so if it is a current device, we have to use the ammeters to measure the gate current, and if it is a voltage controlled device, the voltage measurement is enough to find the conduction proportionate to the voltage or current. And here I connected the voltmeter and ammeter. Now I am connecting the voltmeter, which is used to measure the voltage in between the collector and emitter terminal. Okay, so these are the connections, and we have to give these connections to measure the EI characteristics of IGBT. Okay, so here I connected 500 milliampere meter in the collector terminal, and 30 volt meters in VGE, and to measure the voltage in between the collector and emitter. So that's all, connection is over. So now we are going to measure the output characteristics and transfer characteristics of this IGBT. So here that output characteristics of the device is measured by fixing the voltage applied in between the gate and emitter terminal. So first I am going to take down the readings for the output characteristics of the device. So I am switch on in the power supply. Before that, we should ensure the zero position of each knob, so that protect the devices from the over voltage. So if you want to see the devices, you can turn this kit and you can see the devices in the back side of the kit. Okay, so here they fixed the IGBT with the heat sink. So this is the heat sink, so that can be used to dissipate the heat to the atmosphere, so that keeps the device's temperature within the safe limit. So for that they provided the heat sink, and this is the IGBT. Okay, so here these are the three terminals, so they are taking the terminals from the devices. Okay, and in each module you can see these kinds of arrangement, and the devices will be fixed across this heat sink. Okay, so now I am switch on in the power supply, and I checked the zero position of the two knobs. Okay, so it is in zero position. Now I am switch on in this, and first I am going to measure the output characteristics of the device. So for that I am going to fix the input voltage. So now I am varying the input voltage, and I am going to keep it in the 2 volt or 4 volt. So I am keeping it in 3 volt. So I kept the input voltage, that is the voltage applied in between the gate and terminal, as 3 volt. So now I am going to vary the voltage applied in between this in between the collector and emitter terminal. So when I am increasing this, you can observe that, so the voltmeter is reading, but the current flowing through the collector terminal is 0. Okay, so you have to you have to note down the values of the anode collector current for every increment in the collector to emitter voltage. Okay, so you see here the voltage is increasing, but the current is in 0. So it means that the device is in off state, it is acting like a open switch. Okay, so I am further increasing the voltage to identify the breakdown voltage of the devices, and the device is not breakdown. So it means that there is no enough voltage for the enough voltage is applied in between the collector and emitter terminal. So I am increasing this voltage to 4 volt. So first I fixed this as 3 volt. Now I increased to 4 volt, and again I am repeating the procedure. So you have to note down this reading. So these two readings and this one for drawing the output characteristics of the IGBT. So again I am checking. Now also the device is not breakdown. So again I am further increasing the voltage. Okay, now I am repeating the same procedure, and I am checking whether the devices will comes to breakdown or not. So it is not coming. So again I am increasing this voltage to 4 volt. And the device is not working. So I have to check this meter. So because whether I cannot identify whether these meters is working or not. So I am checking by changing the connection of the voltmeter. Okay, the ammeter is working fine. So there is no issue with the ammeter. Now we can see I am increasing the potential, and till now the device is not breakdown. And you see here, you see the meter, I am increasing the voltage, but the current is settled at a value. So nearly it is 20 milliampere, and further increase in the voltage is not reflected in the current. So that voltage is increasing, but the current retained at the same value. And you have to note down this for the different value of the applied voltage. So if you are plotting the curve, so you will get these characteristics. Okay, so these characteristics is also shown, that the increase in the voltage is not reflected in the current. So after some increment, the current is nearly constant. Okay, so you can get these kinds of characteristics, and you repeat this same for the other values. So then you increase these voltages to higher value 6 or 7, then you repeat the same procedure. Okay, you see that a small variation in voltages, but the voltage is settled at some value, the current is rising. Okay, so you repeat this same procedure for finding the output characteristics of the IGBT for different value of the gate to emitter voltage. So now we are going to do the experiments for obtaining the transfer characteristics of IGBT. So in this case, I am going to keep the voltage, output voltage, or the voltage across the C and E terminal as constant. So I kept this value as 5 volt. And now I am varying the input voltage applied in between the gate and emitter terminal. So you can observe the variation. So this is the meter connected in between gate and emitter terminal. So when I am increasing this knob, you can get the variation in the gate to emitter voltage, and you can see that now the current is 0, and when you are increasing further, that current is increasing rapidly. You see that a small variation in the voltage increases the current rapidly. Okay, you see that there is a biggest variation in the current for a small variation of the VGE. So that should be recorded, and a graph should be plotted in between this gate voltage and this current. Okay, so when you are plotting this, you will get this curve. Okay, a small voltage variation and the large variation in the current. Okay, so this is about the IGBT, VI characteristics and transfer characteristics. So you can conduct these experiments to find the VI characteristics of our IGBT. And these same kinds of procedure should be followed for MOSFET also. So only the difference is the device. So other procedure and the readings and tabulations are similar to this IGBT. Okay, so next we will see the MOSFET characteristics and VI characteristics of the MOSFET. Thank you.